Hey, so it is time for our 3 biomath equations that we need to know how to work for papers 2 and 4. Remember, for AICE Marine, Lincoln's index could be on paper 2. The next equation we're going to go over is Simpson's index. That could also be seen on paper 2. And then Spearman's rank, you can see it on paper 2 or paper 4. So these 3 formulas do not need to be memorized. They're always given to you. So let's start with the easier question, which is going to be Lincoln's index. So Lincoln's index, they usually give you a background of what type of organism they're studying. In this one, it is the blue striped snapper. Now, scientists were using the mark release recapture method, which is Lincoln's index. What happens with mark release recapture, just a background before I get started, is we go to a site, we mark exactly when we went, how the tides were, what time of day, and we want to make sure that we record exactly the location. Then what we're going to do is look for the organism that we're trying to study, mark the organism with a safe tag. Now, these tags are usually put on by something that eventually over time will fall off, or we do look at the fins, the dorsal fins of organisms. Then what we do is we release the organisms and we let them go about their business, whether that's migrating, immigrating, mating, dying, everything. And then we go back sometime later and we look for this same organism in the same location. The tides have to be the same. So remember, everything else has to be the same because it is an experiment. Lincoln's index is to estimate population size. Now, the Lincoln's index, there are some limitations, like these tags could fall off. Organisms could leave the area and not come back, and new organisms could come into the area. We could also see that if an organism dies, we won't see that tag again because it died with the organism. So let's go ahead and look at Lincoln's index. Lincoln's index, remember, I just said that all these formulas are always given. So you don't need to worry about memorizing any formulas, but you do need to know how to work the equation. So we are always given the variables. So capital N is population size. N1 is first sample. So match it to first sample in your table. N2 is marked and unmarked in second sample. Let's go ahead and highlight second sample. And then we have M2, which is number of marked individuals in second sample. So look, marked second sample. So it's important to pay attention to what's in your table and the variables that are told to you in the question. Again, it's embedded in the question. You do not need to memorize any of these formulas. So it says calculate the total population size, and we have to calculate your answer and state it in 3 significant figures. Cool thing is this question is a plug and play. So if we're looking for population size, we know that's capital N. Lowercase n1 will be 52. Times lowercase n2, which is 41, and we're going to divide by the number of marked in our second capture. So 52, we're going to, obviously, you're given a calculator, so you can do this in your calculator. You do not need to do this in your head. You're going to do 52 times 41 divided by 12. In our calculator, we get 177.6 repeated. So it says 3 significant figures, so we have 1, 2, 3. That means we're going to round this number to 178. No units required. Leave your answer, move on. Where are you getting your 2 points from? One is coming from your answer. The other is coming from correct number of significant figures. Let's go ahead and move on to level up, a more challenging question. Simpson's index of diversity. Again, this question, we're given the formula again and the variables. That's always given, coming directly from our AICE exam. The first part of this question, a lot of the time they're going to want you to do a little bit of work before they have you start Simpson's index. So the first part of the question, it says calculate the total number of all species in mangrove area X. Important to pay attention to that. So we have to do a little math here. Total number of mangrove area X. If you add 24, 19, 24, 3, and 5, you're going to get 120. Now you look at the second part of your question, and it says use the formula and the data table 6.1 to complete table 6.2 and calculate Simpson's index of diversity for mangrove area Y. So they're actually not even asking us for our calculated value. The reason why they do this is if they make a mistake, if you make a mistake when you're calculating your response, they want you to have the ability to earn full marks still. So looking at the table 6.2, we have 3 organisms in mangrove area Y that are missing information. So the first part is we have to look at mangrove area Y, lowercase n divided by uppercase n. Lowercase n is different species, uppercase n is all species. So we're going to take the lowercase n and divide it by the uppercase n, which is the total. So for the first one, you wouldn't have to write this on your table, but I just want you to know where I'm getting my data from. So we have 53 divided by 109. That's because we have this Nipah species. Rhizophora, for the first one, we have 0 divided by 109. And then the last Rhizophora is 35 divided by 109. Now, on the line, we would just write the answer. We don't need to take this a step further and write all of our work out yet. Doesn't ask us to show our work. You're going to get 0.47. Why am I doing 2 significant figures or 2 numbers after the decimal? I do that because, this is actually 0.49. I am using 2 decimal places because everything above in the table is to 2 decimal places. What Cambridge gave me, 0.03, 0.13, 0.04. So I'm going to take my answer also to 2 numbers after the decimal. Obviously, 0 divided by anything is going to be 0. And then last, 35 divided by 109 is 0.32. Again, same thing with the numbers after the decimal. Next step, we have to do mangrove area Y squared. So all we're doing is taking our number that we just calculated and we're squaring it. Again, you do not have to show this part, but you do need to show the answer. So 0.49 squared, 0.2401. Why am I going now with 4 numbers after the decimal? Look at what Cambridge gave me. 4 numbers after the decimal. So I am going to follow exactly what Cambridge provided. 0 when we square, and then 0.32 times 0.32, 0.1024. So now we filled in a majority of our table. Not quite finished yet because we have to find the sum. So this works all the way across our table. So you're going to take all of the numbers that were provided and the ones we calculated and just add them. Don't do anything else, just add. When you add all of these numbers up, you're going to get 0.3619. That's the sum for mangrove area Y, n over n squared. The last part, it says Simpson's index of diversity for mangrove area X. We have to calculate Y. So just like our formula, we completed in the table this part. That's the table. We need to do 1 minus our number. So 1 minus 0.3619. I'm following exactly what Cambridge did in their example. Always follow exactly what Cambridge does in their example, unless told otherwise. My answer is going to be 0.6381. Now you have the entire answer and the table filled in for Simpson's index of diversity. The last one we're going to look at is Spearman's rank correlation. Spearman's rank correlation ranks your data based on the number you have. So looking at this question, we have a small reading that comes before our table that describes what the table and the experiment was about. You're going to use that typically on the questions that come after your Spearman's rank correlation. So make sure you read everything on your AICE exam. So you're usually given a graph or a table or both, like we were in this question, to follow, because we not only have all of the information on the table, but we have the information from the table graphed on figure 4.1. So we have a table and a graph. We're going to go ahead and look at the calculation for Spearman's rank. So just like Simpson's, and Lincoln's, we're going to see that this formula and the variables are always given. Now, something that might be a little confusing is we have n equals number of pairs. Just worry about number of items in sample. If you know the number of items in the sample, looking at the number of items, that's how many organisms you studied in the experiment. So basically, that's going to be something that you're using to compare different organisms to each other. So that's your data that you're collecting. So your lowercase n will be 11. So all we did was count how many different species we looked at. Notice the rank here. Not all the time will Cambridge give you the rank. You may have to rank some of the numbers, and we'll take a look at a question where we need to figure out the rank. But keep in mind the rank is going to follow 1 through 11 for this one. Then we have D. D is the difference between rank 1 and rank 2. So that's what D stands for, rank 1 minus rank 2. And then you're going to take the answer from rank 1 minus rank 2 and square it. So if you get a negative number for rank 1 minus rank 2, don't worry, when you square things, it becomes a positive number. So let's go ahead and look at what we need to do. Use the information in table 4.2, that's the table we were just looking at, and the equation to calculate a value for RS, which is going to be our Spearman's rank correlation. Show you're working and state your answer to 3 significant figures. So first, I'm just going to pull my equation, just like you would do when you're taking your test. So you remember where all the variables go. Now that we have that, we can go ahead and start identifying our variables. So we have 6 times the sum of D squared. Here's D squared, just like we did for Simpson's. We're going to add D squared. Don't do anything else except for add. When you add D squared, you're going to get 82.05. So the sum of D squared equals 82.05. That's adding all of D squared. N, remember we said N equals 11. So it's going to be 11 cubed minus 11. Don't forget, you do have a 1 that comes before our parentheses. So I'm going to put that in so you actually see the 1 so we don't forget about it. So 6 times 82.05. On the top, you're going to get 492.3. We're going to divide that by 11 cubed minus 11, which is 1,320. 492.3 minus 1320. 492.3 divided by 1320 gives us 0.37295. We're not quite finished yet. We have to take 1 minus 0.37295. Please make sure you put 1 minus your answer that was in the parentheses. Otherwise, you'll get a false number, which means either a false positive or a false negative. So in your calculator, you get 0.62704. It says 3 significant figures. So on the line, 0.627. And by making sure your answer is to 3 significant figures, you would earn the total 5 marks. So our last equation for chapter 4 is Spearman's rank correlation. This one is a little bit different than the previous one we did, which is we need to figure out the ranks. So sometimes Cambridge makes this question a little more challenging. Previously, they gave us a table that was filled in. Now they're giving us a table that actually is not filled in. So the students needed to figure out the rank, which is you. You're the student that needs to figure out the rank. The first thing I want you to notice is there are 10 quadrant numbers. So that means n is going to equal 10. Remember, like our last equation, n equaled 10. So the lowercase n equals 10. When we look at the rank for the percentage of our cover of algae, we need to match that to the percentage cover of algae. So we're going to look at what Cambridge has provided us. They have 100 ranked at 10. We're missing 9. We're missing 8, we're missing 7, and we're missing 6. So the next thing we need to figure out is after 100, what comes before 100 that we can rank as 9? Looks like that's going to be 95. After 95, the next lowest number is going to be, or the closest number is going to be 80, so that'll be 8. Now we have two numbers that are exactly the same. So if you're ranking, what you want to do is, since two numbers that are exactly the same cannot be ranked different numbers, you need 6 and 7, but we can't change 70 to 6 or 7. We can't separate those two numbers. It's the same number. So you're going to take 6 plus 7 and then go ahead and just divide that by 2. You're actually just going to find the midway point, which is 6.5. So 6.5 is going to be shared by our number 70 because it's the same number. So we're just splitting the difference in our rank. They did this again for the ranking for the number of crabs. So we're going to do the same thing and see what numbers we're missing. We're missing 10, we're missing 9, we're missing 7, and 6. So we need to figure out what numbers we're going to use. So it looks like they are starting at the highest number again. So 22 should be 10. We're missing 9. 25 should be 10. 22 should be 9. Then we look at 20, that's going to be 7 because we already have an 8. We don't have a 6, so 19 will be a 2 and a 1. The difference, which is D, we went over that with our last equation, is rank 1 minus rank 2. So for rank 1 minus rank 2, they have some of the table filled in, but again, what we needed to figure out was not filled in. So 6.5 minus 7 is going to give us negative 0.5. You can put the negative or you can omit the negative, meaning you don't need it, because once you square 0.5 or negative 0.5, you're going to get a positive number. So remember, the next step would be to square our difference. Then 9 minus 10, which is 1. 1 squared is going to equal 1. Then we have 8 minus 9, which is negative 1. You can put negative 1 or you can just put 1. And then, of course, negative 1 times negative 1 is 1. Then we have 6.5 minus 6, which is, again, negative 0.5. When we square it, we're going to get 0.25. So that's how you fill in the table if you are given two numbers that are the same percentage that you need to rank. Now, this is only if you need to figure it out. If Cambridge gives you the answers, don't worry about it. There's nothing you need to correct, only if you have blanks that you need to fill in. Then remember, we do the sum of d squared. So that means we're adding all of d squared up, and that's going to be the sum of d squared, which eventually will plug into our equation. So we're going to add up this last column. You'll get 12.5 once you add up all of your numbers. And then we look at the next part of our equation, or our problem. It says the formula for Spearman's rank correlation is always given, so we don't need to memorize it. We already went over everything and what the variables mean. So let's go ahead and plug this in by showing our work. So we know RS equals 1 minus 6 times the sum that we found, which is 12.5, divided by n, which is 10 cubed minus 10. And then we're going to show our work. So we have to do everything on here. So 6 times 12.5. That's going to give us 75 on the top. So 1 minus 75 divided by 10 cubed minus 10. 75 divided by 990, we're going to get 1 minus 0.07575. It continues to repeat, but we'll just go to our significant figures of 0.07575. Then you're going to take 1 minus your answer, because remember, you do not want a false negative or a false positive. So it's 1 minus 0.07575. You're going to get 0.92. It's really 0.924 in the calculator, and it repeats. However, it does want us to use the appropriate number of sig figs. So looking at this, we should use 2 significant figures based on what we've calculated so far. We have all of our answers, 1 and 2 sig figs, and then we look at our final equation, which is right here. 1 minus 75. What's our lowest number of sig figs in our parentheses? It's 2. So we're going to follow the 2 significant figures that we found. Now, they will accept your answer if you were to write 0.924. However, your points might be, your awarded points might be different. So just keep that in mind. You want to use probably, unless they tell you 3 sig figs, you're going to use anywhere from 1 to 2. And then if they specify, you would use 3. Remember, always use the information that Cambridge is giving you, so it'll make it much easier when you're answering questions.